Hey Lizzie, thanks for this question. I totally understand why you had some troubles like drawing and understanding a diagram for this. I've done my best here. It doesn't look anything like a car, but I think that's okay because at least it doesn't overcomplicate the diagram. From my understanding, I see the forward direction as coming like forward out of the car in 3D almost. The reason I've drawn in 3D is that I can show that I interpret these two forces and these two vectors to be in line vertically with the car, but not horizontally. So I feel like the car is being almost pulled forward in two diagonal directions, and forward out of the bog, not like up, if that makes sense. So that's kind of how I've tried to draw the diagram. I'm assuming the passenger side is on the left, but it doesn't really matter. Right, so now we've got two vectors. We've got their magnitude and direction. We want to find a resultant vector that is the net force. And we want to find both its magnitude and its direction. What I'm going to label this F1 and F2. And I really want to break it down into its own X and Y components. So if we just start with F1. I'm going to look at, okay, we've got, I guess, relative to the forward direction of the car, that's what we're looking at. Alright, so that's what our scenario looks like. And then we can define these two directions as, let's say, this is X and this is Y. And so then we've got f of X is going to be 6,000. Isn't that like a 6? 6,000 sine of 32. And f of Y will be 6,000 cos of 32. Okay, and then I've repeated that diagram process for F2. And actually I should define again, this is Y, this is X. And so now my function, the force in the F direction is going to be 9,000 sine of 39. I'll just pause here, by the way. This is not X and Y in the classical sense, because, and in fact I should probably say, let Y be forward direction of the car. Because X in terms of like a Cartesian plane sense, we usually use cos. So the X and Y nominal here, it's just splitting it into two separate components. One that's vertical, one that's horizontal, if that makes sense. And then f of Y will be our cos variant of that. Yeah. Okay. So what we can see from just the diagram is that their Y values in this sense, their vertical component, their forward direction component, if you will, are both going in the same direction. So we're going to add f of Y, but the vectors that are going in the horizontal X direction, so towards the driver's side or the passenger side of the car, they're going to be opposing. It's like that and then like that. So we're going to subtract those and then find the net. So we're going to subtract the X components. just fx. And so when we do that, we will get net in the forward direction, we'll say, will be 6,000 cos of 32 plus 9,000 cos of 39. And then the net force in the side direction, if that makes sense, like side to side this way, will be, and I'm going to say the absolute value, the difference between 6,000 sine of 32 and 9,000 sine of 39. Okay, I'll put those in my calculator and see what we get. And so I just wanted to quickly touch on this. There's a little bit of a point of contention here. So I've subtracted these two horizontal components, and that's because I believe that one is acting in this direction, the other is acting in this direction. And so when I did that, this part was larger, meaning that the force is acting towards, I believe, the passenger side. Yes, the passenger side, you could say. But I will note, like, this all, like, whether or not you subtract these ones, all hinges on the fact that these angular references mean from the x direction outwards rather than like an angle of elevation. If they're an angle of elevation, then you would actually be adding these together. Because if they're both angles of elevation, and you've got one that's like that, and then you've just got another one that's like that, or I guess I'll do it in a different color. Another one that's just like that. It's there, and it's there. Then, well, their y components and their x components are both going to be acting in the same direction. So I'd be adding them together. I'm going to be honest, I don't know what the question means in terms of that. This is my gut feel. That might be wrong. And I'd love for you to like let me know what the answers say in the comments. That'd be really helpful. But I feel like this is what I first jumped at. That makes sense in terms of angle to the forward direction. But yeah, that's where there'd be a bit of a discrepancy, right? This is always going to be added together because we're moving the car forward, right? But whether or not we're moving the car up or they're pulling just on the same vertical plane, I'm not actually sure. In this instance, we're saying they are, and in that case, we're subtracting our two horizontal vectors, which will give us a net force in this direction here, which I'll highlight this one. Okay, so given that, we can draw a little net force vector diagram. We've got our 12,000 acting in this direction, and then our 2,000 acting in this direction. And so we can create a triangle, right angle triangle, and find the magnitude of this net force and its angle from the forward direction as well, probably is most appropriate. And as long as we reference that relative to another direction, that's okay. So this is, again, 1282.6. This is 2484.7.37. So to find the net force, we are just going to do our square root. So the magnitude of the net force is square root of each of our components squared. So I'll put that in my calculator. Okay, so for that I get 12,335.37 newtons all up. approximately, of course. And then define direction. It's going to be this angle in here because we said this was this forward red component. And we want to find it relative to the forward direction. And so how we can find that is going to be the opposite over adjacent, so the tan ratio, or the inverse tan of this side length over this side length, and again I'll put that in my calculator. Okay, and that gets me 11.62 degrees or thereabouts. And I kind of always like doing a little bit of an eye test with the angle, and I feel like that roughly makes sense. It's not going to be greater than 39 degrees in that direction. It's going to be somewhere in here, just slightly slanted to this side. So I feel like that makes sense contextually. If, once again, I put a disclaimer that if it's the interpretation here is right, that we haven't elevated our winch pulling at all. So all in all, these are our key answers. So a magnitude of this and a direction of this, importantly too, from the board direction. So this magnitude at this angle from the forward direction would be my answer. Cool. Definitely a difficult one, Lizzie, and I might definitely be wrong. So I'd really love your feedback on that. But yeah, I still hope you found that a bit helpful. The maths there and how we manipulate the vectors is applicable regardless. So yeah, I hope you found that useful. If you did, we'd really appreciate it if you could support the channel, whether that's just giving this video a like, subscribing. Yeah, I'd really appreciate it. But thank you for the question, Lizzie. I hope to hear more from you in the future. And yeah, appreciate it.